Hello and welcome to a slightly different video. This time we do not have a tutorial for you, but we are trying out something that seems to be a hot topic everywhere right now. We are talking about ChatGPT. ChatGPT is, without giving it enough credits, just a chatbot. But it is a very versatile one with impressive knowledge and features, as you will see in the next minutes. Computer-generated art has been a topic for a few months, with tools like Midjourney appearing in the news every few days. With this comes the debate if those artificial intelligences will take away jobs from us biological intelligences. We don't see these as a threat for us or as competitors. We like to see them as powerful tools that can reduce the time spent on more mundane tasks, but still need some deeper knowledge to find the correct phrasing to get them to the output that will solve the problems we present. What we will be trying today is to present ChatGPT with a task that we had to tackle in one of our projects recently. We were working with splines, in our case cubic Bezier curves, and we had to calculate multiple interactions between them. This could be, for example, an intersection, or, and that will be our example for today, if a point in 3D space is on the curve. For this we need to know what the closest point for a given point in 3D space on a predefined Bezier curve is. We have a solution for this, but it is not optimized or tuned for execution speed or memory consumption. At the end of this video, we will try to profile both our and ChatGPT's solution and see if we could improve some things. We begin our endeavor with a simple question that lines out what we want to achieve. And we have to admit that we were a bit surprised when it started to write down this nicely formatted C# code right in front of us. It is visible that it is one of the more basic options to solve the problem, as it is sampling the curve with a fixed set of sampling points, which can lead to problems depending on the type or length of the Bezier curve. Also, because it relies on the sampling interval, the closest point might not be overly accurate. And at the end, there is something that sounds like it might lead to problems. The comment in the code indicates that there might be results that are not the overall minimal distance, but one of multiple local minimal distances. But first, let's see if the AI thought of everything. And of course, intersecting curves are also covered. And since it already mentions the problem of local minimal distances in its answer, let's try to fix that little oversight. And here we encountered a problem for the first time. The code is cut off and the explanation is missing. But since we are not really happy with the sampling approach, we try to go the route that we went with our own approach: divide and conquer. And without missing a beat, we get a new method that explicitly uses a divide and conquer strategy. And just to confirm that we are not missing anything, we again ask it if it will be the most closest point on a Bezier curve. And of course, this will be the case with this algorithm. In the answer, there is a hint about the threshold parameter, and by looking at the code a bit more closely, we discovered that the threshold is used for the distance to the target, which was not our intention. So let us try to correct that. And instantly we get a new method that uses the threshold for the length of the current segment. As we can see, this approach is recursive and does the sampling of the curve in each iteration. That is not the best solution, so let's try to fix that. Again, we had a problem with the answer stopping before completion, but from the code we can see that it does the caching nicely. But wait, there should be more. Now comes the part that can usually take much longer than the initial implementation of an algorithm: finding ways to optimize it. And of course, we will try to see if ChatGPT can do this for us. And surely it can. Reading the first optimization, we were a bit disappointed. Of course, we could reduce the number of sampling points, but that would also increase the error in our results. That does not sound like a good optimization. But it quickly redeemed itself with the other recommendations. The second one kind of describes what we already have, so we skipped over that one. The third one mentions the De Castillo algorithm. That name rings a bell. Far back at the university we learned how to efficiently calculate Bezier curves with, you guessed it, this algorithm. Skipping the fourth option, multithreading and parallelization, that's a deep rabbit hole, we went for the cheap win. After a short hiccup, we managed to get the whole answer using the De Castillo algorithm. Let's see if we can optimize it further. The response looks quite familiar this time, so we will just look at the last one. The first three are basically the same as in the first optimization suggestions, but the fourth one suggests using another data structure for storage. Let's keep that in mind for later. Since it keeps on hinting at the sampling points as a point of optimization, why not try to go for an adaptive approach? We got only a partial explanation this time, but looking at the code, we see that it's still using fixed intervals to sample the curve. Maybe we have to rephrase our request? After a few retries, we get a full answer, and it looks like we were successful. Again, in this recursive method, the sampling is done over and over. Maybe we can fix the adaptive approach and the sampling problem in one go? It took a few retries, but we persuaded the bot to give us the full answer. And since we are never satisfied, let's try to optimize again. This time we get a few new options. Not paying much attention to the other options, the possibility to lose the recursion was tempting. This switched out the recursion for a while loop, indeed an interesting approach. Just to make sure that we are still on track, we checked if it will always be the most closest point. And reassuringly, the algorithm told us that it will. Just a little bit unsettling is the mentioning of the threshold, as long as it is small enough. That sounds like a source of errors. But we wanted to try something else first. An early break in this method should be if the point we are looking at is already on the spline. Then we would not have to do all the calculations, so we try to incorporate that. And we get our modified code in no time. But here the sampling is back. Let's try to get rid of it again. Well, this made a bloated mess out of our nice and compact method, and we are not 100% certain that it does what we want. So we went back to the previous version. Back to our old version, we again tried it with the optimization. Options 2 and 3 are similar to what we got before. Use a binary search and use a better data structure. But interestingly, the first option tells us to ditch the deCastellion. Wait a minute, didn't you recommend it a few minutes ago? A little bit confused, we try to offload even more of our own mental work to the bot. We were not expecting that much, but to our surprise, it had good explanations for the optimizations it recommended. It gave us detailed explanations why another algorithm would be better, why another data structure would be better, and also that it would be best to profile these things to identify specific bottlenecks. The answer is very elaborate. Much less elaborate was our next request. Again, we ran into a few problems where the bot would stop writing the answer, but in the end we got an optimized version of the method. Now, the last step would be to get this as a complete script to simply copy and paste it to our project. This again threw it off and we needed a few tries to get to the end. The usual explanation was cut short this time, so we tried to get the bot to repeat it. But it just repeated a summary of the getClosestPoint method. Then we thought that maybe, if it can provide a file download, that would be easier. But unfortunately, it just repeated showing us the code. There is a copy code option in the upper right corner, but if the text is not complete, it is not very useful. Well, we then tried to run another round of optimizations. And we got a new version of the method, without more explanations what has happened. But since we are very curious, we just asked. And much to our surprise, the AI told us that it made an error, and simply repeated the last version of the code. But instead of just being sad, it added multiple optimization options to its answer. And here things got a bit interesting. Again, there seems to be a more efficient algorithm, so why didn't it tell us about it earlier? And the hint about caching? Didn't we already ask it to implement it? The third one we explicitly asked for. And the fourth one is again parallelization and multi-threading. For the moment we want to avoid it. But the other three, let's give it a shot. And with the new code we get a new explanation. And this is where we stopped tormenting the AI and switched over to Unity to see how this method compares to our solution. Before we start running any tests, let us take a quick look at the code we will be running. As we said in the beginning, these methods are straight from one of our projects and they may not be pretty or optimized, but we are almost sure that they work as intended. Since we are doing things a little bit different from what ChatGPT wrote, let's see if we still know what we did last summer. Basically what we want to know is if a given target point is on a Bezier curve. In the end, it is a simple yes or no question. And that is exactly what we want to hear from our point is on Bézier curve method. Either true or false, nothing fancy. What we did was calculating the t-value for the closest point on the Bézier curve with our approximate t method. For example, if the closest point on the curve is right in the middle, it would be a t-value of 0.5. If it is right at the start, it would be 0 and 1 right at the end. For this t-value, we calculate the point on the spline and the distance to our target. If it is below our precision threshold, we assume that it is on the spline and return true. In any other case, we return false. GetPoint does exactly what the name suggests. It calculates a point on a Bézier curve defined by 4 vectors and a t-value. The real meat is in the approximate t method. We went for a recursive approach that splits the spline in 2 parts by using the t-value midpoint of each segment as the cut line. For each segment, we test if the target is closest to the start, middle or end point. If it is closer than our epsilon, we are done and return the value found. Otherwise, we split the segment into smaller parts and repeat the check until we find a t-value that is below our epsilon. The ChatGPT variant is copied 1-to-1 from the output of the bot. We only added a point is on Bézier curve method to it, which gives us the same entry point as we have with our own code and also the same results, just a bool value. Now we will take a look at the testing methods. We decided to run the test 100 times in each call with 100 randomly generated pairs of Bézier curves and target points. As you can see here in the Bézier setup method, that we simply use random.insideUnitSphere to create our randomized vector 3 values. We do this for the Bézier curves as well as the target vectors. The method is marked with the setup attribute, so this is run before any of the tests will be calculated. To get a performance comparison, we use the performance testing package from Unity. As you can see, both tests have a loop over the 100 pairs of curves and vectors. To measure the execution times, we use the measure.method call. We also define an iterations per measure count of 100 and a measurement count of 100. This means that we will run the test 100 times for a single measurement and repeat this 100 times. In total, we will do 10,000 tests for each of our variants. Now it is time to see how this works out. In our Unity editor, we will use the test runner window to execute our tests. We selected only the 2 tests that we just added and click on Run Selected. This will take a few seconds, and when we see the green check marks, we know that the test is done. Now we head over to the performance test report window. And, even to our own surprise, our method takes the lead. We are almost 3 milliseconds faster on average for each test run. This came as a surprise even for us. We looked at the code and couldn't find any problems with the testing method or any obvious errors we made. We also did a boring check with a few example values, and both methods get to the same results for the same datasets. A large-scale unit test of both methods is beyond the scope of this video. So, what is the message here? Will AI take our jobs? Will we ever need programmers again? Our opinion on this is a bit relaxed. We don't really see it as a threat. AIs like ChatGPT are tools that we can use to streamline our work. But they will not make programmers obsolete. First, as we, to our own surprise, discovered, their solutions are not always better, faster or more efficient than what we made up. Second, and that should be clear from watching the creation process, it still takes a person with deeper knowledge of what the goal is to accurately define and refine what we can get from an artificial intelligence. Someone still has to read and understand the results to be able to incorporate them into a bigger project. Without knowing what the code does, it is difficult to know if the answer is in fact an answer to the question asked. Imagine you want to build a car, but you are not a trained mechanic. You can acquire all the parts, screws and the equipment. But without knowing what is what and where it goes, you will most likely not end up with a functioning or safe car. But this definitely was an interesting test, and we will keep an eye on the development of ChatGPT and other tools. We hope that you found this interesting as well, and we would like to hear your take on the topic in the comments. Thank you for your time, and see you in our next video.